In this presentation, we're going to look at the trigonometric functions. More specifically, we're going to look at the graphs of these functions and talk about some of the terminology that comes up with the graphs of the trigonometric functions. So when you're ready, proceed to the next slide. Here, first one we're going to look at is the sine graph. So we're going to plot the graph here today of y equals sine theta. So the first thing we're going to do is make up a table of values. So if we go to our calculator and put in sine of 0 degrees, we get the answer 0. If we put in the answer sine of 30 degrees, we get the answer of 0.5 or a half. If we put in sine of 60 degrees, it comes out as 0.87. Now, the next slide has all these numbers nicely typed out for you. If we go sine of 90 degrees, it equals the value 1. If we go sine of 120 degrees, it also is 0.87. Of course, we could be going to our unit circle here. Here's 120 degrees here, and the sine value is the y coordinate. So I'd be reading across to here, and we get 0.87. Sine of 150 degrees, we read across here, and we can see that it's 0.5. Or we use a calculator. Sine of 180 degrees is the y coordinate here. The y coordinate here is 0. 210s, we're now getting to the negative y values, so this is actually negative 0.5. Sine of 240 is negative 0.87. We can be doing these on our calculator. Sine of 270 degrees is down here, so the y value there is negative 1. So remember, sine is the y coordinate around the circle. 300 degrees, we get back to negative 0.87. So you can see here there's a lot of symmetry in our answers. Negative 330 is negative 0.5, and back to 0 here, the y coordinate is back to 0. Okay, so now we want to plot these points. So when theta is 0, y is 0, so plot that point there. When theta is 30 degrees, y is 0.5, which would be this coordinate here. When theta is 60, y is 0.87, so it'd be approximately here. When theta is 90, y is 1, which is this coordinate here. And if we keep going through, I won't read all through them, so I'm just going to plot the points as I read through the table. You can do the same on your notes. 0.5, 0.87, negative 0.87, negative 1, negative 0.87, negative 0.5, and back to 0. Okay, once we have all our coordinates here, now we can draw a smooth, continuous curve. Now I'm going to be doing this freehand with a mouse, not so easy. You're probably better off trying to do this in two parts. The top part of the circle here, so of the graph, which will look like this. And then you continue on and go down and try and go through all the points. We will have a nice version on the next page, but that's the graph of y equals sine theta. It has a maximum value here at 90 degrees of 1 and has a minimum value down here at 270 degrees and negative 1. And it crosses the x-axis at 3 times, and the y-intercept is 0, 0. Okay, we have some terminology we discuss with graphs, with these sort of graphs. If I was going along here, when I get to 360, we would find this graph would continue in the same fashion that we started there. Okay, so the graph repeats itself. So the length it takes this way, it takes to repeat itself, is called the period of the graph. And quite often these graphs are called periodic graphs. And lots of things in real life are modelled by these graphs. Wave motion is a very familiar one. You might see graphs on oscilloscopes. I'll forget it. They're periodic graphs where we get wave motion. Sometimes they're called wave graphs. So here we say the period of the sine graph is 360 degrees. That's the length it takes before it starts repeating what's happened. Alright, that's how they can predict tides and things like that for surf and stuff like that, because the tides follow a very similar graph to the sine graph. Alright, also the other terminology we talk about the graph is how high the graph goes up or down from what we call the mean position. So this is the mean position of the graph, is the halfway, if you divide the graph into half horizontally. So this is called the mean position. And the length or the height the graph goes up or goes down is called the amplitude. Okay, so I'll just write the word up here, amplitude. Normally we just write amp for shorts, but it's amplitude. And the amplitude of the sine graph is equal to 1. It goes 1 up from its mean position, or it goes 1 down from its mean position, but we just say the amplitude is 1. We don't say positive or negative 1. So the amplitude of a sine graph is 1 and its period is 360 degrees. Okay, if we go to the next slide, we can see a nice, neat version of this. So make sure you've written in the amplitude and the period of this graph. Then proceed to the next slide. The second graph we're going to look here is the graph of the cosine of theta. So plotting this graph y equals cosine of theta. So once again, if we put in our calculator or some of these values we should know from our exact values. So cosine of 0 degrees is actually equal to 1. Cosine of 30 degrees is 0.87. 60 degrees it's 0.5. Similar numbers to the sine graph here. Cos of 90 degrees is the x value at 9 degrees is 0. 120 degrees is negative 0.5. We're going to that second quadrant where cos is negative. In 150 degrees it's negative 0.87. At 180 we're back to 0. We're at negative 1. Next slide has all these nicely typed out. 210 degrees is negative 0.87. 240 degrees it's negative 0.5. At 270 degrees it's 0. 300 degrees it's positive 0.5. 330 degrees it's 0.87 positive. And when we get back to 360, the value of cos of 360 is 1. So now we can plot all these points. So this cosine graph starts up here. The y-intercept is at the coordinate 0, 1. And then goes at 30 degrees, it's 0.87, which is about there. 60 degrees is 0.5. 90 degrees, it's 0. Then we get to negative 0.5, negative 0.87, negative 1, etc. I'm just plotting the points now. You can plot the points by reading the table. It should be similar to mine. Just check that you're putting the points in the same position. Okay, once we've plotted all the points there, we can join the curve up in a smooth curve. So watch the way I try and draw this. It's a bit hard with the mouse, but I'll try my best. So it goes down like this. I've gone a little bit low there, comes back up through here and then starts to flatten out towards there because it starts turning down again. And before we talked about the period, so here the period of the cosine graph is how long it takes before it starts repeating itself, and it's 360 degrees. And the amplitude, we talked about the amplitude of the cosine graph is how high or low it goes from the mean position. The mean position once again is along the axis here, so How high up does it go? It goes up 1, goes down 1. So we say the amplitude is 1. Not positive or negative, just 1. Okay, it's got two x-intercepts here at 90 degrees and 270 degrees. Maximum value goes up to 1, minimum value goes down to -1. My graph probably should have been more like this. A bit better, not marginally better. It's flat there and goes up like that. That's much better. Anyhow, should only be one line drawn though. So could use pencil and rub that out. If we go to the next slide, we'll see what it should look like. Here we go. And that's a much nicer version of it. Just the two things you should be adding there is make sure the nice type values, the nice values here, and talk about the period and the amplitude. Which we said was 360 degrees and the amplitude being 1. Okay, if just as a matter of interest, we can, I don't want you to do this to your graph, but if I split the graph into 4 sections, every 90 degrees, representing our 4 quadrants, you can see that it's positive here, negative, negative, positive. Remember we had our little circle here, we had A, S, T and C. Cos is positive in the first quadrant, just like over here. In the second quadrant only sine is positive, so therefore cosine is negative, negative values down here. Third quadrant, negative values again, because only tan is positive there. And in the last quadrant, cos becomes positive again. Okay, and keep in mind that this graph is going to start repeating itself. And we can go in both directions, and it'll start repeating itself. The other thing you'll notice once we start drawings repeat, a cosine graph is, if I continue like this, a cosine graph is very similar to a sine graph, but they're 90 degrees difference. This is really starting at negative 90 degrees here. Okay, if we're going out into the negative direction, this would be negative 90 where it starts, and you can see you get a sine graph. So cosine and sine are very similar graphs. In fact, they're just, one's been shifted along compared to the others. How much has been shifted? 90 degrees. Alright, we'll stop there and we'll proceed to the next function, the tangent graph. Okay, here we're doing, ooh, that should be written tan there. I'll fix that in your notes. Here we're looking at the tangent graph, so we put in the angle into the tan, so tan of 0 is 0, tan of 30 comes out to 0.58, tan of 60 degrees comes out to 1.73, tan of 90 is undefined. Alright, which will make our graphs interesting. Tan of 170 degrees jumps down to negative 1.73. Alright, so there's something different happening with these graphs. Tan of 150 is negative 0.58. So we're starting negative, getting a bit more positive. Tan of 180 is 0. Then it becomes positive 0.58 for 210 degrees. And then positive 1.73 for 240 degrees. But we find it once again 270 degrees, we don't have a value, we can't work out the tan, so we say it's undefined. At 300 degrees it jumps back down to negative 1.73, then it goes up to negative 0.58, and tan of 360 degrees is the same as tan of 0 degrees is 0. Okay, so now we have a table of values, we can plot these points, so when theta is 0, tan of theta is 0. When tan is 30 degrees, here we get the value 0.58, it's about here. Tan of 60 degrees is 1.73, so it's going to be somewhere up here. Tan of 90 degrees it doesn't have a meaning, so when we come across that in mathematics, we draw a dotted vertical line saying this graph is not allowed to touch this line because it's not equal, it can't be equal to, it's undefined. Alright, we'll just plot the points first. 120 degrees, tan is negative 1.73, so that's way down here. Negative 0.58 is going to be somewhere about here. 180 is 0. Positive 0.58, so it's going to be there. 1.73 there. 270 degrees is not equal, so put this dotted line in again. So tan has sections where it's not, where it can't be equal. 300 degrees is minus 1.73 is about there. Negative 0.58 is there and gets to 0. Okay, the graph here is going to look like this. It's a smooth, continuous curve, right? Not jumpy. So this one, I'll try and draw a nice version of it. Starts going like that and starts heading down this way. So we put arrows on the end of it, and that last bit here seems to be repeating again. Okay, how long does it take before the graph repeats itself? So if we think about, if we start here, the graph goes up to here, then it jumps down to here, then it gets to 180, and then it starts repeating itself. So the period of this graph, right, the period of a tan graph is different to sine and cos. Here we say the period is 180 degrees. It's half the period of a sine and cos graph. And we talk about the mean position here. The tan graph once again is still at this position here. But we don't talk about the amplitude. So the amplitude, because it's going to go up to infinity, we don't talk about the amplitude of a tan graph. We only talk about the amplitude of a sine graph or a cosine graph. So that's the graph of tangent of theta. There's a couple of things we need to add here. So I'm just going to think. These vertical line, dotted lines that I've drawn at 90 degrees and 270 degrees, these are vertical lines. We've already learned how to draw the equation, write the equation of these lines back in when we did straight lines. All vertical lines are of the form x equals whatever the number is. So here we'd say this vertical line has the equation x equals 90, and likewise we'd say over here x equals 270 degrees. And we have a special name for these lines in mathematics, where the graph gets close to, you can actually see up here, you can see the graph is going upwards and outwards. It's going to get close to this line but never equal to it. And down below here, same thing, it's going to go down and keep going down and get closer and closer to this line, but it'll never be equal to it. We have a name for these lines in mathematics, so we've got two on this diagram. They're called asymptotes. Okay, and that's a fancy word, asymptote, to explain that the graph approaches this value but will never equal it. So up here we said 90 degrees and 270 doesn't have an answer. Alright, it's just undefined. That's what we need to be writing in there. It's undefined. Because the tangent line, the graph, those points will never meet the tangent line, so it doesn't have a value. So it's undefined. And we call these lines asymptotes. So maybe we'll make a plural because there's two of them. If we go to the next slide, we'll show you a much better version of all this. Okay, once again, that should have the word tan there. Very careless of me. Okay, so there's the values there, the exact values, and this is what the graph will look like. Once again, if we keep extending this graph, it's just going to keep repeating itself. And there'll be another asymptote here. Add another 180 degrees on from 270, so that'll be at 450. And the graph would go up like this, etc. Alright, and if we went over to the left, the graph would come down like here. So therefore, my vertical asymptote here would be at negative 90 degrees, because it's 180 degrees between here. That's the period. It's 180 degrees. but we don't bother talking about the amplitude of a tangent graph. Okay, now next we'll about to proceed to the next slide. Okay, here's a summary of those three graphs. So if you're looking at your three graphs here, the amplitude of the sine graph was 1. The amplitude of the cosine graph was 1, but we don't talk about the amplitude of a tan graph. The period of the sine graph was 360 degrees. That's how long it takes before it starts repeating itself. The same for the cosine graph, and the tangent graph we found was half that of those two, 180 degrees. The maximum value sine can go to is to positive 1, and the maximum value cosine goes positive 1, but the maximum value tangent can go to is infinity. It just keeps going up and up and up. There's no limit to it. The minimum value for sine is negative 1. It's also for cosine. So cosine and sine are very closely related. So the properties are very similar. For tangent, it goes down to negative infinity. Right, the x-intercepts for the sine graph, we have them at 0, 0. We had the next one was at 180, 0, or 180 degrees if you want to be more accurate. So 0 degrees. And the last one at 360 degrees, 0. For the cosine, there was only two x-intercepts between 0 and 360, so we're only considering up to 360 degrees here. So we've got the first one as at 90 degrees, 0, and at 270 degrees, 0. Once again, on the next slide, you'll see nice values of these. For tangent, the two x-intercepts in this range, for this, what we call the domain, between 0 and 360 is 180 degrees, 0, and the other one was at 360 degrees, 0. Remember, we should write our intercepts as coordinates. Our y-intercept for the sine graph is 0, 0. For cosine, though, it was 0, 1. Remember, all y-intercepts have the x value 0, and for the y-intercept for the tangent graph was also 0, 0. So if you look back at the graphs, you can see that. If we proceed to the next slide, you can get a nice printed version of that. Okay, make sure you got those into your notes, please. Here we have two examples that we need to do, so I'm just going to split these into two. So let's concentrate on the first one. Y equals 2 sine theta, which means 2 times sine theta. Now, we already know how to plot the graph of sine theta, and now we need to multiply it by 2. So every y value is 2 times as high. So the first, you might remember when the first point was 0, 0 on the sine graph, and multiply the y value by 0, 0 times 2 is 0. The next y coordinate was 30 degrees and 1/2, which was here, but we're going to multiply it by 2, so this graph we're drawing is going to go through this point. The next y value at 60 degrees was 0.87, so we're going to multiply that by 2, so it's going to be roughly about 1.7 something or other, which is about here. The original sine graph at 90 degrees was 1, so multiplied by 2 we get up to positive 2. Coming back down the same, we work out the same things, that this is twice as big as the number that was here for 120. For 150 it was here, so twice that is there, but it's 0 times 0. So this graph here, 2 sine theta, the first half is looking like that, as compared to our graph of y equals sine theta, which is looking like that. You can see the graph is twice as high. That's what that 2 here is doing. If we continue on like this in plotting our values, we'll find that the graph's got to go down through here and also here and here. I'm just picking some easy values to try and draw here. So it comes down like this. So this is the graph of 2 sine theta. The normal sine graph would have looked like, trying to change the colour here, there we go. It would have looked like this. So we can see the red graph, which is our graph we're asked to draw up here, is twice the height in both directions of the graph of y equals sine theta. Makes it twice as big. So here we'd say the amplitude of this graph is 2. The period, the graph is still won't start repeating until it gets to 360 degrees, so the period is still 360 degrees. Okay, this next one we probably need to use our calculators to work out values here. If I put, so we're looking at cos of 2 theta, so for example, if I put 30 degrees in here, this becomes y equals cos of 2 times 30. So that makes it cos of 60. And if we go to our calculator, I remember our exact values, the cos of 60 is a half. So the cos of 30 degrees, that's the value I've put in, I get a half. So this graph is going to be here. Cos of 0 is 1. Cos of 60 degrees, we're going to find some negative value down here. It's going to be negative a half. And cos of 90 degrees we find is negative 1. This pattern repeats itself. So we're plotting the points and I can work out from the calculator. And so this graph here is looking like this. Remember, it's still got a bit, still the cos graph, so it still should look like a cos graph. That looks a bit like a cos graph. And what we find is it's going to go through these points. And so this is what the graph looks like. So we can use our calculator to plot these values. I've done it quickly. Now, we're asked a couple of questions here about the amplitude of the graph. From the mean position, it still goes up 1 or down 1, so the amplitude here is 1. And here the period, though, we can see that the graph, if I put an imaginary dotted line down the middle there, the graph starts repeating after 180 degrees. Okay, let's try and summarize what we see on this page. First of all, we can see when we have the 2 at the front here, it changed the amplitude. So if the number at the front of the rule determines the amplitude. So you can see over here, the number at the front here is a 1 and the amplitude is 1. Okay, now let's talk about the period. If it's just plain theta, we find the period is 360 degrees for a sine or a cos graph. But here you can see when I put a 2 here, that the period now is half as much. So we'd say that's actually 360 degrees, the normal period, divided by this number. Where's this number coming from? This is this number here inside the rule. So that's the period divided by that number. That's the shortcut. We call this number n sometimes. So we sometimes say this rule is the period, the normal period, or 360 degrees, probably better writing it like this. So the normal rule we use is this. We say it's 360 divided by n, and n being the number here. This is what n is. In this case here, there's no number here, there's actually a 1 here. So n is 1, 360 divided by 1. Okay, so just while I've got your attention, if the rule was y equals tan 2 theta, we'd find the period would be 180 divided by 2 because the standard tan graph has a period of 180 degrees, so the period, this would be 90 degrees before it starts repeating. So just be careful of that. And you should be able to now attempt the questions from the exercise. So if I go to the next slide, you can see the nice neat versions of those. And if I go to the slide after that, you can pause here if you want to copy them down. Go to the slide after that. At this time, it's probably a good idea for us to have a look at how we use our calculator to do some of this work. So first of all, I'm going to add a calculator page. We've already seen previously we can use the trig menu here. So if I want to do sine of 60 degrees, if I go Control Enter, it'll tell me it's 0.866, etc. Or if I just went Enter, it might tell me it's root 3 on 2. Your calculator needs to be in degree mode at this stage to get these values. So I can do something like sine of 300 degrees, press Control Enter, and it tells me it's negative 0.866. Right, bit of symmetry going here, 60 degrees and 300 degrees are very similar values. We need to work out the sine's negative in the fourth quadrant, that's why it's negative 0.866. Or if I just went Enter, I'd get negative root 3 on 2. Alright, more importantly, I want to talk about graphs in this one here, so I'm going to go to Doc and insert a graphs page. Alright, there's a couple of things we need to check before we start. Even though we've got our calculator in degree mode, we need to make sure the calculator is working in degree mode for graphs. So we click on Menu and go to Settings, and you'll see here it says Geometry Angle Degree. If not, you need to go down there and select Degree. If that's what it's got, then we can go OK. So up here I'm going to type the graph of y equals sine x. We need to I typed that. We'd better off going from the menu, going sine, and you've got to put x in here. It doesn't matter if it's theta or some other letter in question. When you're using the calculator, you've got to be in terms of x, so I've got to put x here. I'm going to do this with just sine of x to start with and press enter. And we look at this and we go, well, that doesn't look very good. It doesn't look like the graphs that we've drawn before. The reason is we're only going from minus 10 degrees to positive 10 degrees. Now, there's a quick way we can change the scale here using the calculator. If you go to Menu and you go to Window Zoom and go down to Zoom 8, which is Trig, and you'll see it then changes it. Because we're asked for degrees, it starts from negative 360 degrees and proceeds through to positive 360 degrees. At the moment it's going up to positive 4. We know this graph only goes up to positive 1, so if you want to get a bit more shape about your graphic, let's make this a 2, and I'll go down here and make this negative 2. So it looks more like the sine graph we drew in our things. If we didn't want to go into the negative direction here, but this gives you a good idea to see how the graph repeats itself every 360 degrees. If I change this number here, I'll just double click on this and tab over to here, and if I make this 720, twice as far out, you'll see I get the sine graph goes up and back here and then starts repeating itself every 360 degrees. Anyhow, I'm going to change this to 0. I'm going to keep that as positive 2, and I'm going to change this one to 360. And there's our graph going from 0 to 360. Remember, you can use the analyze thing on our graph here. We can get our 0. Remember, the 0's there. Because that's 0. Because I can't go to the left, but I can't get the one 0, 0, so I might double click on that tab, and I might just go to negative 10. Alright, then if if I go to menu, analyze, that's 0, I can get this one here, 0, 0, and the same thing's going to happen out here. There's one at 360. We can also find the maximum value. You get to the left of that point and scroll across until it tells you the point there's a 91, and analyze the minimum, which is this point down here, as a 270, -1. Okay, there's our sine graph. On the same axis, I'm now going to draw the cosine graph, so I'm going to press Tab, and here I'm going to go to the trig menu, select cos of x, press enter, and so the red graph there we can see is our cos graph. We can mark a few points, the maximum of this graph here. It's also got another maximum out to the right there. I don't know if it'll allow me to do this. Yeah, it won't, because I can't go past 360. So I might escape off that. I might do the minimum though down here, this graph, so down here. Alright, I can work out the x-intercepts, so menu, analyze graph, 0 of this graph, go from here to here, and menu, analyze graph, the 0 is the x-intercept, go from here to here. So you can see all those key points. Normally in a cosine graph and a sine graph for one period, there's 5 key points. Have a look here in the red graph, 1, 2, 3, 4, and this other maximum up here. For the blue graph, the sine graph, 1, 2, 3, 4, and the end point here, the other 0. Probably, I'll just make this 400, just so we can see these. I'll just mark these points in now. Maximum, this one from here to here, and menu, analyze graph, we've got the 0 of this graph from here to here. Okay, so you can see there's 5 key points for one period of both a sine and a cosine graph. If I just going to go back and show you how we can draw these graphs so it doesn't go beyond 0 and 360. So I'm going to go up to the first graph, the sine graph. If we say we only wanted to draw for a certain values of x or theta, we do this. We go Control equals, and we select this separator line. And here we can say we only want 0, Control equal again to get it less than or equal to x. Control equals to get that less than or equal to 360. Okay, this says I only want to draw the graph from 0 to 360 and including those numbers. And then you can see it's cut off those bits that were going out at the end. It's just going from 0 now to 360. So I'm going to do the same to the red graph. So I press Tab, go up. So I go Control equals, gives me that line. 0, Control equals, select less than or equal to x, Control equals, less than or equal to 360, and you can see now the red graph is only going from those values. Interestingly, it changed my 0 point there because you won't be able to change that, I don't think, to 0. It doesn't like it. That number there is 0.00000209, which is almost 0, isn't it? It's the way the calculator works this out. The numbers on this screen here aren't necessarily the exact values. You've got to remember that about the graphs. Alright, that's those graphs here. I'm going to go Document and go Insert a New Graphs. Right, when you go a new graph, settings are all changed. Don't worry too much about that. So the two examples we did, one was 2 sine of theta. So we're going to make it x, and we are going to say only one from 0 to 360. So 0, Control less than or equal to x, Control equals less than or equal to 360. Press enter. Right, and if I do that menu, Windows Zoom Trig, you can see there it's got a whole lot of E's I don't need here, so I might as well make this 0. And then we can see that graph that we're asked to draw before, so we can use the calculator to help us. I'm now going to put that other graph on part B of that example, so I'm going to go tab, and that graph there was cosine of 2 theta, so we've got to write 2x. Once again, I want to restrict what values we're looking at, so we're going from 0 to 360. So we have to use less than or equal to symbols to do this. Press enter, and then we can see that we get this cos graph, get 2 periods of it in that cycle there. And you'll notice that there's 4, so if I make that 2, the first graph goes up to 2, the second graph only, the purple graph only goes up to 1. Well, that's, I might as well make that one -2 as well. Okay, so you get a better idea of the graph. If you double click on the scale here, if I say make this, I'll make it 0.5, we can see it's going up to 1, 1.52, so it's a bit easier to read the scale. Across here I can see the scale here is, well, I'm not too sure what's going across in, so I can't see the scale number there, so I'm going to go menu and go to Windows Zoom again, but this time I go up to Windows Settings, and here it says the X scale is going from 0 to 360, but it says auto, so I'm going to go up in lots of 30 degrees and go OK. So each of these dashes now is worth 30, so it's a bit easier to read the graph. So you can change that. So if I went back and did the same thing on this graph here, so menu, Windows Zoom, Windows Settings, I'm going to change this to steps of 30. I'm going to change this Y scale and steps off 0.5. Go OK. So it's a bit easier to read the graph like that. Alright, so that covers quite a bit about how to do these graphs on a calculator. Once again, you need to be in degree, and the menu settings, you must be, geometry angle must be in degrees. Okay, so we'll leave that at there. And you can see which questions we need to do from exercise 20.6. Thank you.